All right, section 7.1. We are beginning chapter 7 now. In this first section, we're going to talk about adding polynomials. So remember, a polynomial is just an expression, a math expression that contains variables, constants, or exponents, and different operations happening between those things. Now, for adding polynomials, what we really want to focus on are like terms. So remember, like terms are terms that are either whole numbers, so all whole numbers are like terms with each other, or all real numbers, and any term with the same variable and the same exponent. So for example, I have 4x to the fourth, and I also have 8x to the fourth. Both of those terms have the same variable, x to the fourth. So they are like terms, and I can combine them. Likewise, this minus 1 and plus 7 are like terms because there's no variable attached to them. They are just whole numbers. So we can combine both sets of like terms that I just highlighted. So for the red ones that I highlighted, we have 4x to the fourth and 8x to the fourth. And the operation that's happening is we're adding. So I know these parentheses might kind of throw you off, but just think about this as they're just grouping these together, but then you're adding it to this polynomial. So we'll take 4x to the fourth and add it to 8x to the fourth, and then we'll take -1 and add it to +7. So first, 4x to the fourth plus 8x to the fourth, we are going to add the coefficients, so 4 and 8. That would be 12, and our variable does not change when we add the terms together. So 12x to the fourth, and then if I combine -1 plus a +7, you can use your calculator if you need to, but that should be +6. So we're just finding the like terms and combining them. All right, now let's look over here. So I have a 4n to the fourth. My next term is 4n to the third. So these are not like terms because while the letter of the variable is the same, the exponent's different, and that's very important. We cannot combine these two. So I have 4n to the fourth, 4n to the third, 6n to the fourth. So n to the fourth here, n to the fourth here. Those are like terms. I'm going to highlight that the same color. And then I'll notice I have 4n to the third, and then I have -8n to the third. And those are also like terms because they both contain n to the third. So combining them respectively, 4n to the fourth plus 6n to the fourth, we're adding the coefficients, so that would give us 10n to the fourth. The variable does not change. And then 4n to the third, or 4n cubed, minus 8n cubed. We are going to take +4 and subtract 8, or you can think of it as taking +4 and adding -8. Either way, you should get -4n cubed. All right, go ahead and pause the video and see what you get for problem C. All right. So I identified 6n to the third and -2n to the third as like terms, and 4n squared and 3n squared as like terms, and I combined the coefficients and got 4n cubed plus 7n squared. The only thing that's weird about this one is we had been seeing a pattern of this term and this term were like terms, and this term and this term were like terms, but now these two are like terms and these two are like terms. So sometimes the order might get flipped, and as you'll see in the next few problems, some other weird things can happen as well, which brings us to problem D. So now we have polynomials with 3 terms in them. So our first polynomial here still only has 2 terms, but now this one has 3 terms. So a polynomial can have as many terms as it wants. So these can get very big. But for this problem, let's just start. I always like to start with the very first term. I'll highlight it one color, and then I'll look throughout the rest of the polynomials and see how many other terms have that same variable and are like terms. So if I kind of cruise along here, that's not a like term, that is, it's just an n, so I'll go ahead and highlight it. If I keep going, end of the fourth, nope, end of the third, nope. Okay, so these two are like terms. I'm gonna pick a different color now, and now I'm just gonna go to the next term that I don't have highlighted. I'm gonna highlight it, so 6 end of the fourth, and once again, I'm just gonna cruise along till I find more terms that are like terms with the same variable. So we have another 6 n to the fourth here, so that is a like term. It has n to the fourth. I like to highlight the whatever the operation is in front of numbers, so that way I know if it's positive or negative. I did forget to do that over here, I guess. And then if I keep going, my last term is not a like term of this either, so it's all on its own, so I'm going to highlight it a different color. And now we just combine the terms that are highlighted the same color. So first we have 2n plus n. And remember, if we have plus n and there's no coefficient in front of it, we can assume there is a 1 there, because if I put 1 times n, that is the same thing as n. Because if I multiply anything by 1, that does not change its value. So 2n plus 1n is 3n. And then just to keep track, I'm going to go ahead and cross off anything that I've already combined. So we added those, so I don't need to worry about them anymore. Next, we have a positive 6n to the fourth plus a negative 6n to the fourth. So if I take those, I have 6n to the fourth, and then I subtract 6n to the fourth. 6 minus 6 is 0. So this will all just turn into nothing. So I can just cross those off. If you want to keep track, you could write down plus 0n to the fourth, just so that way you know you did add those together and you didn't forget to. But you don't have to include it. That's just if you would like. And then our 8n to the third, there's no like term to combine it with, so this just stays untouched, and we'll just bring it down into our answer. So you could write your answer like this, or you could write it without the 0 n to the fourth. That would be a little cleaner. But if I saw this on a quiz or a test, I would count that as correct. All right, moving on to problem E. Very similar. We have a polynomial with 2 terms and a polynomial with 3 terms. Go ahead and pause the video again, try it, and see what you get. Okay, so I wrote my answer 2 different ways, but first, just to show how I got it, so I had 2n and 2n combined to 4n, 6n to the fourth minus 4n to the fourth gave me 2n to the fourth, and then the negative 6n cubed just got brought down because there was no other like terms for it. Now, this is mathematically correct when we look at the numbers. We got the correct values and everything. However, when we're writing our answer, it is best when we have the same letter variable just with different exponents in its terms. It's best to write it in descending order, or the smallest variable first and then larger variables after that. Or you could even flip it and write the largest variable first all the way down to the smallest variable. So you could rewrite it this way, where I just flipped these 2 terms, but I kept the same sign for each one. Or I guess you could write it, if I flip it with the variables going in this order, 2n to the fourth minus 6n to the third plus 4n. This is the most acceptable answer that most of your teachers would like to see. So you have the largest variable first, all the way down to the smallest variable. But for this class that you're taking currently, if you route any of these answers, I would accept them. Okay, we have 2 more, and these are both very big problems. So we are going to do problem F together, and then I'm going to leave G for you to do after this video. So let's take a look at problem F. Let's just get our highlighter out, and let's start going to town. So first, I have a term, and the variable is v to the third. So I'm scanning to see if I have any other terms with that variable. Looks like I have 1 more right there. So let's go ahead and highlight that. And that is it for v to the third. All right, pick another color. My next term that's not highlighted is negative 5v to the fourth. All right, I'm looking for v to the fourth. I see one right here. Highlight that. And then if I keep going, I actually see another one right here. So we'll highlight that one as well. I forgot to highlight the sign. Okay. Next, new color. Highlight the next term that is not highlighted. And now that is v squared for our variable. So let's see if we have any more v squareds. Nope, doesn't look like it. Let's pick another highlighter color. I'm running out of colors. All right, we have 8v. Do I have any v's just by themselves? Nope, looks like my last two are whole numbers, but those are gonna be like terms since they are whole numbers. So a ton of highlighting, but if we just go one color at a time, we can make some good sense of this. So I'm gonna continue color coding. So for the red highlighted numbers, we have 7v cubed plus positive 5v cubed. So I'm adding 7 and 5. That is going to give me 12v cubed. All right, so that is it for my reds. Moving on. Now I have my greens. So I have negative 5v to the fourth, plus 2v to the fourth minus 3v to the fourth. So you can plug this in your calculator if you want. So we have a negative 5 plus a positive 2 minus a 3. So we have negative 5 plus 2 minus 3. I believe that will be negative 6v to the fourth. If I'm wrong and you're watching this video, come up to my desk and let me know. Next, we have 8v squared, but we said there's no like terms with that variable. So we're just going to bring that down. So plus 8v squared. Next, we're looking at purple. So purple, we have 8v, which again had no like terms. So we will just write plus 8v. And last but not least, we had our oranges. So we have negative 2 plus 6. Again, use your calculator if you need to, but negative 2 plus 6 is positive 4. Okay, now I'm just going to slightly rewrite this. I'm not going to change much, but I do want to write this in descending order. So I have my first term should be the variable with the highest exponent. So in this case, that would be v to the fourth. I know it looks weird since there's going to be a negative in front of it, but we'll just write it like 6v to the fourth. And then I believe the rest of these terms were in order. So after v to the fourth would come v to the third. So plus 12v to the third plus 8v squared plus 8v plus 4. All right. I know these are long, but it's the same process. So go ahead, try problem G. If you think you got it, then unpause the video and double check.